This is an example of the ambiguous case for the law of sines. So it asks you to determine the number of possible triangles based on the constraints that we see in the picture. So we start by setting up the law of sines with however much information we have. So in this case, I know that little a is 12 and angle A is 71 degrees, so I can set this up like this. And I also know side B, but I don't know angle B, so I set it up like this. So I go ahead, I cross multiply and solve the way I normally do with the law of sines. So I should end up putting into my calculator 17 times sine 71 over 12, and that will give me whatever sine B is equal to. This gives me approximately 1.33. Right away, I know that this is a problem because sine can never be greater than 1. So if I go to my calculator and do sine inverse of 1.33, I should get something that tells me I have a domain error, and I do. So in this case, we would say there are 0 possible triangles that can be created. Here's another triangle, and I want to know the same thing, how many possible triangles. So I'm going to go ahead again and set up the law of sines. So I can put 8 together with sine 27. And I also know the side that's 15.5. Let's just call the angle across from it x. And so I need to find out what x could potentially be. So again, cross multiply and solve. Okay, so I should be typing into my calculator sine 27 times 15.5 divided by 8, and that will give me the sine of x. So I get that sine x is approximately equal to 0.88. This is good news so far because that number is not bigger than 1. So I'm going to go to my calculator and I'm going to do sine inverse of that decimal. I get that x would have to be approximately equal to 62 degrees. So here's where I stop and think, okay, is there another option? So what I do to figure this out is I start by subtracting that angle from 180 because this means that there's another possible angle in quadrant 2. So when I subtract these, I get 118 degrees. And now the check is I go back to the angle that they gave me in the original triangle, and if I add that with 118, I need to make sure that does not exceed 180. And this gives me 145 degrees, so that's actually okay. So this means technically x could be 62 or 118. So there are 2 possible triangles.